Welcome to another episode of Motales. I'm Dave's minion, CudaPete, and today will be the first in a series of 5 videos regarding the supply of parts to the Chrysler Corporation in the mid-1980s from the quality assurance perspective. A little bit of background about myself. At the time, I was an engineering student at the University of Detroit, and as part of the engineering curriculum, co-op was required. I was fortunate enough and privileged to get a job at the Chrysler Corporation. I worked as a supplier quality assurance specialist in procurement and supply, supplier quality assurance, powertrain components group. Powertrain components consisted of anything that really bolted onto the engine, excluding the engine itself, meaning the fuel system, the exhaust system, cooling system, all sorts of tubes, hoses, pipes, grommets, and gaskets. And in this, I was responsible for surveying outside suppliers to make sure they maintain consistent quality in the parts that they supplied to Chrysler. So our series is going to be broken down into 5 episodes. The first today, which we'll start off with, is engineering. So the first thing that we have to remember is that at the time, about 2/3 of the parts of the car were outsourced, meaning they were manufactured by an outside supplier other than Chrysler. Chrysler made approximately 1/3 of the car. So in order to do that, we had to provide clear and specific specifications and drawings to the suppliers to make sure they knew what was required. So on the drawings, there were some critical things that were called out. The first was a shield. This meant it was a government regulation. It usually concerned safety, emissions, or noise, and those absolutely have to be complied with. Then the second was a diamond. This was considered a critical dimension, but not regulatory. It may be an SAE, ASME, or AISI specification, and it was important to the dimensional, functional parts of the car to make sure that they worked properly. And then there was the Pentastar. The Pentastar indicated a Chrysler internal standard, which was also critical to the part. So as I said, this information was provided to the suppliers so they knew what was expected of them. Now, the parts could be one of 3 things. The first was a black box item, which meant this is already designed and developed. It's an off-the-shelf part. It already exists. Something like a spark plug, a battery, a tire. So the engineers would select one of these already existing items as a black box that would meet the specifications and could be used on the car as is. The second was in-house design, but outside manufacturing, meaning the design department at Chrysler would design the part, but they would not build it in-house. They would send it out to an alternate supplier to have it manufactured outside. And the third type was outside design and developed, or what was known as odd box. This was using an outside supplier's expertise in a particular part and rely on them to design the part and manufacture it. And it had to meet the specifications, but a lot of the responsibility was put on the supplier in this case because they were considered an expert in this area. So all this information was provided to the suppliers in a package, and then they would bid on it through the purchasing department, and then contracts would be established for the parts, and then they would be manufactured. Once it was determined if it was going to be a black box, an inside design, or an outside design, then the engineers had to look at certain things to make sure they were delivering a quality part. And the first thing would be the FMEA, Failure Mode Effect and Analysis. And there was a manual for that. In this manual, it details how to go about doing an FMEA. So what is that? You take a part and you look at it and you say, what happens if it fails? Maybe it's just a minor inconvenience. Performance is not as good, or it's a cosmetic problem. Or it may be something more drastic, such as a loss of a braking system or a stalling of the car. So they had to look at all the different aspects of what was possible. What happens if this part fails, and what is the impact of that failure? And then obviously try to minimize that so that the part would not fail. So that was something that was important to look at. But then how do you measure that? How do you measure the success of your part? A lot of people just look at, well, it looks good, it performs good, but you really need a metrics on how to do that. And how do you develop that metrics? There was what we call design of experiments. So design of experiments is a way of scientifically looking at a problem and developing a solution that has a measurable result. And that's usually done through what's called the Tamaguchi method. It gave a scientific approach to developing tolerances and specifications, and then at the end you had a metric where you could measure a result, whether it was successful or not. So this was another aspect of what was used during the design of the parts. And then all this information was provided to the suppliers so that they knew what the requirements were, and then they could begin manufacturing the parts. In our next part of the series, we'll start looking at what actually happened at the suppliers and supplier quality assurance, so how those metrics were measured. So if you did like this video, be sure to like and subscribe, and I thank you very much for watching.